Hello and welcome back. So from this video onwards, we are going to discuss about the numerical features. So I'm going to introduce few things related to the numerical features before we deep dive into it. So first of all, let us understand two kind of numerical features, which are linear and the non-linear features. This is very simple to understand. Like when we talk about the linear features, then it means that we are talking about those features where the dependent variable, suppose the y is equal to mx plus c. This is the equation. So in this equation, the dependent variable is y and the independent variable is x, right? So this equation, which is the equation of a straight line, y is equal to mx plus c, this shows a linear relationship between the independent variable and the dependent variable. So it means that whenever we will put some value into x, then the value of y, whatever it will come, there will be a linear relationship between those two, right? So every time you will be trying any linear equation, then you will get some straight line, right? Something like this, A, B, or maybe like this, C, D, something like these. I mean, every line will be a straight line whenever you are talking about the linear features. So y is equal to mx plus c. This will always give you a linear this is a linear equation which will always give you a straight line, right? And when we talk about the non-linear features, then those non-linear features look something like this. You can see this is a parabola. Okay, this is known as a parabola, or you can say like when you draw something like this, and you get something like this, right? So this is an ellipse, right? So these are the curves which are known as the non-linear curves. For the parabola, you can see like the equations are like y is equal to y square is equal to 4ax plus c, something like that, right? So there is something related to, power to the dependent or the independent variables, right? So those kind of curves usually form some kind of shape which is not a straight line. That is something which is not linear. So the linear equations are always in the form. So first, let me show you the linear equations. So linear equations are always in the form ax plus by plus c is equal to 0. This is a linear equation. And the non-linear equation are in the form like ax raised to the power n, a1 x raised to the power n, a2 x raised to the power n minus 1 plus a3 x raised to the power n minus 2 plus up to plus a0, right? Is equal to 0. Something like this, right? So one example you can see like ax square plus bx plus c is equal to 0. This is a non-linear equation, and the top one is a linear equation, right? So what is the use here in the feature engineering or in the machine learning? What is the use? Why we are learning these things? So let me give you a simple example. Suppose uh, we are going to create a model, right? And the model is going to predict something, right? Suppose, for example, there is a student, right? There are students. There is one, not one student, there are number of students, right? So we are able to understand that if a student is studying um, 2 hours, then he is able to get 70% of the score, right? If he's going to study about 4 hours, then he's going to get around something around, it's 2 to 70. It may be like, it could be like 35, and then 4 is like 70%. And then if you see like 3, so let us make it 30 so that I can show you clearly. 30%, then if he's studying 4 hours, then he gets 60%, and if he studies 3 hours, then he gets 90% marks, right? So if you draw a plot, a curve, then in that case you will be able to get a straight line. But is it always true that if a student is studying 2 hours, then always he will be getting 30%? Or maybe he is more focused and he may get 90%. That could be the thing. And the one who is studying 3 hours, right? It's like 6 hours. Then in that case, maybe not three, it's like six. So if he's studying like 6 hours, then maybe he's only getting 40%. Maybe his concentration is not high, right? So we can say that whenever we are creating a prediction model, or whenever we want to create a model, or whenever we want to predict something, then based on the data, right, based on the whatever data we have available, based on that data, or based on the available notions, we cannot always say that there will be a straight or linear relationship between the independent and the dependent variables. What is the independent variable here? This is the number of hours, which is a independent variable which can take any value, and this is the marks, 30% marks, 60% marks. So these are the dependent variables. These are dependent on the number of hours you study, right? So these students who are getting 30%, 60%, 90% marks, their marks are dependent on the number of hours they study. Okay, so this is how the things doesn't work in the real life, because there is no linear relationship always. It may be that the person who is, or the student who is studying only 2 hours, he is getting around 80% marks, and whosoever is studying 4 hours, he is getting 90% of the mark. But yeah, whosoever is studying 6 hours, he is not getting 90% or 80%, he is only getting 60%, right? So maybe he is not that focused, right? Maybe he is focused, but yeah, he is hardworking, but he he used to rather than understanding the things, he used to learn the things by heart, and then he just understand doesn't understand the things, just learn it by heart, and then um, he goes to the examination hall, and then he is able to perform something well, right? So even after reading 4 hours, studying 4 hours, he is able to manage 90%, only 10% more than this guy who is studying 2 hours only. So there is not always a linear relationship, right? There is not always a linear relationship. So whenever you are creating a model, then you may not be able to find out any equation like y is equal to mx plus c, where you put the value of m and c, sorry, well, where you put the value of x and you decide the value of m and c, to find out what should be the ideal equation in which I should put the value which has been asked by the user, and then we will be able to predict that what should be the value, what should be the number of marks it will find, right? Suppose someone says that we are going to draw this curve where this is showing the number of hours, and this is showing the number of marks, I mean the marks only. So the h is the number of hours studied, and m is the marks. So we draw a line which comes like this, right? But but in real life, this will not be a straight line. If it was a straight line, then in that case, we can have a simple equation: y dash is equal to mx plus c dash, m dash x plus c dash. Why? Y dash and x dash, sorry, not x dash, only m dash we are changing. I mean, y dash will be different, right? It will differ from the usual y, right? And we are going to take the value of m dash and c dash. We are going to find out the value of m dash and c dash. Why we will find it out? Because every time it will not be straight line. So what we will do, like, we will try to find out that line which which is very much nearby all the points, which are very much condensed in a specific area. So in the specific area, when it is condensed, we are trying to find a straight line which is which is equidistant from each of the lines, from each of the point, right? So in that case, what will happen, that sometimes you may get this kind of line, you may get this kind of line, but you will try to adjust a line and find a line which is equidistant from all the points. So obviously, when you are trying to find out a line, then obviously what is changing? The c dash. I mean, the intercept is changing. And also m is the slope, right? If you are trying to find a suitable line, then obviously you are trying to get a slope which is m dash and the c dash. So you are now trying to get a new m dash and a new c dash, so that you can create a prediction model, right? Because every time it will not be, straight line. Every time, maybe some points will be on the top, because it may be that some person who is studying only 2 hours, he is getting more marks rather than the other one. So these kind of points you will be able to get, where you are not able to draw a straight line, but you have to find a straight line, where you have to ensure that the straight line that you are finding to predict the model, create a prediction model, you are finding such a line which is equidistant from all the points, so that it is the best suitable line. It will not predict accurately, but yeah, it will predict 90%, 95% with accuracy, right? So finding out that line is known as the linear regression in the machine learning model. This is a big topic, but I'm just giving you a simple example here. So that is known as the linear regression. But sometimes it may be that the points that you are plotting, those points are something like this, right? They are not creating a kind of good curve, right? But yeah, they are not creating a straight line kind of thing, right? Some points are here, some points are there. So it's not somehow you are able to find out a straight line which is equidistant from every point, right? From the data point, right? So in that case, what you will do, you have to understand that whenever you are getting such kind of points where the points are not equidistant from a imaginary straight line, whatever you can draw, then in that case you can go with the polynomials, ax square plus by plus c, something like this, right? You can go with this kind of things because these lines create a kind of parabolic shape. So the parabolic shape will cover most of the points which are not equidistant from a straight line. Whatever you are trying to find, you are not able to find a straight line. So whenever you are going to do that, you have to find out some curve which can be fit into a polynomial equation, right? So you can find out something like where ax square plus bx plus c, something like this. You are able to best fit the equation in this format, right? So in that case, maybe all the points which were uh, spread all around, those points will be covered mostly through these equations, which are the quadratic equation, or you can say the polynomial equation, not the linear equation, right? So in the previous example, we took the example of the number of hours studied and the number of marks, or the marks found, right? Marks is equal to hours into m plus c, something like this was the equation, right? So now what we can do, from the existing variable, independent variable, hour was the existing independent variable, we will get another variable which will be hours square, right? So you have hours already, but you will get one more, hours square. Why you are getting this one? Why you are trying to do this? Because you have to fit into these kind of data points which are spread all across, and something like a kind of parabolic or kind of curved shape they are taking, right? So in that case, you have to do this, right? After plotting the graph, if you are able to see that, yes, this is the thing we are able to see, that we, whenever we will be drawing the things, then after drawing the graph, then in that case, we are not able to find a suitable line which is equidistant from each of the point. Rather, we can go with a quadratic equation, or you can say a polynomial equation, which will be better suitable for drawing the graph, which is where the graph is nearly touching each and every point on the curve, right? Whatever curve you have as a result of your data set, right? So in that case, we are going to use the polynomial regression, right? So in the polynomial equation, what we do, from the existing features, we create new features. Like existing feature was hours. So we have created hours. And even after creating hours, you are not able to fit your curve, then you can go with the hours cube as well, right? You can go with the hours cube as well. So it will become like ax cube plus bx square plus cx plus d. But do you really need to do this programmatically? No. All these things have been done in the Keras library, and there are other libraries like not in the Keras, basically NumPy libraries are providing necessary support, and scikit-learn, these libraries in the scikit-learn specifically, we will be able to see in the coming videos, and in the previous videos as well, we have seen like how you create the program using the scikit-learn library, scikit-learner library. So scikit-learn library, if you see all these things, wherever you are going to do the polynomial regression, in that case, the scikit-learn library will be used, and you don't have to worry that how the perfect line will be, or the perfect curve will be drawn, and how to decide whether I have to take hours cube or hours square or hours up to 4 raised to the power 4, whatever it has to take, that will be decided by the scikit-learn library, right? And you just need to find out like what will be the degree of the polynomial, and how you will decide that. You will draw the graph. After drawing the graph, what you will do, you will try to give the different powers to your to your equation, right? In the scikit-learn library, you will be providing there is a API in the scikit-learn library, and you will be providing the power, the degree, right? The degree of the polynomial. After providing the degree of the polynomial, you will be drawing the curve. And after drawing the curve, if you are able to see from your curve that yes, I'm not able to fit into properly, then you will keep increasing your degree, right? And I mean power, right? So after increasing the degree or the power, you will be able to see that at what point I'm able to touch each of the point, touch most of the points, right? 90% of the points, or we are nearly creating a shape which is covering each and every point almost, right? So in that case, you will be reaching out to a particular prediction equation. So every time what you will do, you will draw a graph. What we follow when we are creating a prediction model, we draw a graph, a chart, right? Draw a graph, then create an equation, equation, prediction equation. That equation could be a linear equation, could be a polynomial equation. And after predicting the equation, you will check. How you will check? Draw the graph again, right? How to check? Draw the graph again after creating a prediction model by deciding the power of the equation, right? I mean, after deciding the degree of the polynomial, you will be drawing a new curve, and based on that curve, you will be checking that what is the how it is performing, like how my graph is looking like now. Is it touching each and every point that I have plotted? If yes, then you will stop. Otherwise, you will keep doing this thing, and you will keep trying to find like uh, at what polynomial degree it is able to give me the best result, right? Give me the best equation. I mean, touching each and every point. The curve which you have created is touching each and every point of the not exactly each and every point, but almost all of the points. I mean, very much nearly looking like this is touching each and every point, right? So something like that, if you find, then that will be your polynomial equation, right? That is known as the polynomial regression, right? So this is the basic understanding of linear versus non-linear, and why we do linear and non-linear regression, why we perform these things. So usually we try to find out a curve based on the linear equation, in the linear fashion. But if the points are dispersed all around the graph, all around the chart plotted, then in that case, what we will do, we will try to increase the degree of the polynomial. We will make it non-linear from the linear equation. So whenever you increase the power, your linear equation becomes non-linear, right? Your equation, I mean, your plot or a plotted graph will become non-linear as soon as you increase the power on the dependent variables, right? Independent variables, sorry. So on the independent variables, as soon as you increase the power, you will become more nonlinear. You will become nonlinear, right? So this is the significance of linear versus non-linear features. And in the next video, we are going to see that how we are going to use these linear and non-linear features. Okay. So till then, have a nice day and